Good day, everyone. Welcome to Life Sciences Grade 11. My name is Duduzile Kupega. My email address is dgupega2204@gmail.com. I provide this for you guys so that you can easily access me even after class. And if you have any questions or queries or need assistance, really anything, as long as it's about life sciences, I'm very happy to help. Oh, not just life sciences, actually. If you're applying and you need career guidance, I'll be there. Anyway, we are doing the topic of human urinary system, the nephron. We started with a bit of it yesterday, remember? We are continuing with the nephron. This is work we covered yesterday, so I'll move through it quickly. Then we are moving on to today, functioning of the nephron. There are 5 main processes that occur in the nephron. And it is made up of different types of epithelial tissues to suit its function at different places along the tubule. So we need to understand those different functions. We will learn them and look through them. Remember, I showed you the diagrams yesterday. Can you identify the Bowman's capsule and tubules in this micrograph of a nephron? Can you guys? Guys, I really want you to talk to me. Okay, before we continue, actually, let's pause class right now. I want us to do Kahoots one of these days. I know it helped with one of my classes. They were like, you guys, they didn't like talking to me, but as soon as we started playing Kahoots, people participate. Would you begin to doing that, even if it's just you? Would you begin? Quickly type in a yes or no, ne? And if yes, then I'll try and prepare it one of these days to test it out if it will work with us or not. But it's fun, it's interactive. You get to also understand the work we've done, and yeah. So now the functioning of the nephron, these are the 5 processes. I'm sorry about this numbering. We've got process 1, 2, 3, 4, 5. Remember, it's 5. The first one is the ultrafiltration. Second one is reabsorption. 3, it's tubular excretion. 4, it's tubular secretion and pH control. And then 5, it's the urine formation. So it's various stages that we need to go through. The process 1, or the first process, which is ultrafiltration. What happens? Remember, this is the whole topic of excretion, right, in the urinary system. So we understand how this urine is actually extracted. How does it come about that it's urine? Because you eat foods, you drink water or juice and all other things. How does it come about that you end up having this waste product, which is urine? So this is what happens here. The stage is where it's ultrafiltration. Ultrafiltration process 1. It will help you to remember it. Let's go through here. Let's go back to this one. I want us to draw this. It's U-R-T-T-U. Probably it will help you to memorize it better and remember it. The ultrafiltration, it separates the waste from blood proteins and corpuscles. So this waste is separated from blood protein and corpuscles. The afferent arteriole, remember we learned about the afferent one, which is wide. Remember the difference in the structure. The afferent arteriole's wide diameter allows the blood to enter the glomerulus. So blood will enter through the afferent arteriole because it has a wide diameter then. And then blood pressure in this glomerulus is very high, so the process is quick. There are pores in the very thin squamous layer of the capillaries of the glomerulus. Then the podocytes in the Bowman's capsule will filter blood. So podocytes will do what? The process, the functioning of podocytes is here. The podocytes are found in the Bowman's capsule, right? They will filter the blood into the capsular space. So it filters the blood into the capsular space. The podocytes have extensions that help with filtering. The filtrate is small particles of water, glucose, amino acids, vitamins, mineral salts, urea, uric acid, and creatinine. Large particles, which are mainly the blood proteins and corpuscles, stay in the capillaries of the glomerulus. So let's go look at them. I didn't remove these today because I want us to go through them. Here's the afferent arteriole. This one here, that wide in diameter. That blood will go in through here. It will go in through here and then over this route, right? Then the podocytes, as you can see them, they have many filtration centers here. You see, all of those are able to assist in the filtration. That's where the blood is filtered, whereby you remove and separate these molecules. Remove and separate the molecules there. Is it clear to see? They are filtering the blood into the capsular space, this space here, this one, just let me highlight it, this color, this one that I'm highlighting. They filter this blood into the space. Then that one with the smaller particles, such as the creatinine, you know, that one, uric acid, it's filtered into this space. But the one carrying the large molecules, it will remain, and then it will be transferred to them. It will remain in the glomerulus. And the capsule there, it will remain there, and then in the cells, capillaries there, it will remain there. But the one that is filtered will go here, in the space here. So you understand this diagram. I'm gonna refer to it as we learn the different processes. So that's the process of ultrafiltration. You remember filtration, you probably have had your first experience of filtration when you, I know when I was young, you know what do you call the tea bag, guys? Help me out. Have you ever had those tea bags that are not in the bag? What do you call them? It's so funny because chances are you guys don't even know them. But then when I was growing up, we had those tea bags. Like I can't even call it tea bag because it wasn't in a bag. But that substance, those things that are the tea was not in the bag. But it was the tea, so you just put it in your tea like that. But obviously, you can imagine how difficult it is to drink when it's not in a bag, since it's many, many grains. So to make sure your tea is nice, we would filter it through a sieve, sort of. So you imagine after making your tea, then you need to filter it through a sieve. So that was the part of filtration. You are separating the substances. You want to leave these grains on one side, and you want the tea, which is now the water, and it's the solution now of the tea, on the other side. You also did such experiments in class. I'm hoping you did it, depending on your school, really, because our education system and our schools are different. But in schools, there's the filter paper, which you would put in a funnel. Remember that, you'd put in a funnel, and then you'd have your filter paper, which you put over there, and it will filter. So maybe you pour in water with sand, and only the water will pass through. That was how it was filtering. It was, I don't know, it was tea for us. Someone is asking if it wasn't coffee. It was tea, guys. I know. Hey, I'm going to find that picture tomorrow. I want to show you that. I'm telling the truth. We made tea like that. And now our host, guys, he says maybe it's coffee. He's filter. Oh, there is filter coffee. You see, I can tell where you probably come from. But yes, for you guys, you probably make filter coffee. But for me, our conditions weren't so great growing up. So that was like the cheapest. So the cheapest alternative, instead of buying the tea bags, which were more expensive, we'd opt to buy the cheaper one, which you could afford, which was not in the bags. So that's why I would learn to filter. But I'm just trying to explain the process of filtration. But like he's saying, there is coffee, there's filter coffee as well, whereby it works with the same process. You are filtering, you are separating the components. The large ones will remain on the paper, and the liquid will pass through with the smaller particles. So that's the process that is happening. Yes, Halalelo, guys, Halalelo. I think Halalelo is sitting with her grandmother. She says, Gran says it's called loose leaf tea. You see, grandmother would know, I'm telling you. So thank you for that. The grandmother knows. It is the loose leaf tea. Yes, you see, she drank it too. So we all we really, thank you for that, Halalelo. It is the loose leaf tea. It was the cheaper option. Yeah? but it explains the process of filtration. It explains it perfectly because you won't be able to drink your tea nicely, so it will leave the larger particles there on the sieve and the rest will move on the other side. Basically, Tina, we called it itiele nkambi. So I'm not sure, probably you can't even understand that if you're not Zulu, so yeah. Anyway, that is the process of filtration. So whenever you remember process one, remember my tea story, guys. Ne? Remember this filtration. That's what happens. That's what the blood is sieved there. Then the larger molecules will stay in the glomerulus, but the smaller ones with the liquid will then pass through to the space here, to that other space, this capsular space, that one I highlighted. I hope that's clear. I really want you to do well in this part. Process two, it's the reabsorption. So you're done with the filtration, ultrafiltration. It's called ultrafiltration because it's still just filtering at the highest level. And then reabsorption. With reabsorption, this process retains useful molecules such as the glucose, amino acids, and water into the blood. Remember, they were separated during ultrafiltration. So now it is returning the useful molecules because they were sieved and they moved out into that capsular space, right? But now the blood can't just go out with nothing. So what happens? The useful molecules will then be returned to the blood. These useful molecules are glucose, they are amino acids, they are water. They will be returned to the blood. This process is either passive through diffusion and osmosis, or active through active transport using ATP energy. This is grade 11. Oh, I was doing it with grade 10s. But anyway, you should have done this in grade 10 where you learned about the process of diffusion, osmosis, and active transport. Diffusion and osmosis are passive processes. Why are they called passive processes? They do not require an energy input. That's why it's said to be passive. The opposite of passive is what is active. So active transport requires ATP, which is a form of energy. And what's the difference again? Diffusion is the movement of molecules or substances from a high concentration to a low concentration. Osmosis is the movement of water from a high concentration to a low concentration. But with active transport, it is going against the concentration gradient, whereby it is moving from a low concentration to a high concentration. So that's how active transport differs from these other two. And because of that difference, because now it's moving against the concentration gradient, it now needs an energy input to facilitate and help it move across that gradient. But if it's passive, then it's just easy. It's like normal conditions, things that happen normally, freely. You are able, when you slide down, you know, when you get on a slide, maybe a water slide, it's easy to just slide through because you are going down that gradient, right? It's moving, it's flowing. But with active transport, it's when you are trying, for active transport, you are trying to climb up a water slide. So you understand how different that is now. You are now trying to climb up a water slide. All the force is pushing it downwards, and you are trying to go the opposite way. So you will need an energy input to assist you to move up. So that's, please remember that. Think of the water slide when you explain these two processes, and then it will be easy to remember. Ne? And then the single layer of the cuboidal cells, they have mitochondria. Mitochondria for ATP energy, and the microvilli to increase the surface area for absorption. Mitochondria is the powerhouse of the cell. That's where energy, cellular respiration takes place. Why am I mentioning cellular respiration? Because that's where, that's the product of cellular respiration. One of the products there is ATP energy, right? So the cuboidal cells have that mitochondria for the purposes of having that energy, ATP energy, to assist during that active transport. It also has microvilli. Microvilli are there to what? To increase surface area. And I always mention this, that when there's an increase in surface area, it assists that particular structure to perform better and we've explained this when we did the last topic, when we did human gaseous exchange. Remember, one of the requirements for the gaseous exchange organs is for them to have a surface area, a large surface area. With a large surface area, the process of absorption happens easy, especially for diffusion and osmosis. And since it's a passive transport, there's a larger area, larger ground for the transport or the passing through of substances to occur. So whenever you see any structure having a large surface area, it actually aids in that functioning of that particular structure. It is good for that structure. So remember these ones. These are important to remember and understand. Osmoregulation now. Osmoregulation is an important function of the kidney. The hormone, which is ADH, it's antidiuretic as hormone, is secreted by the hypophysis gland in the brain, and the hormone detects how much water needs to be reabsorbed back into the bloodstream. Water is then reabsorbed by the distal convoluted tubule and loop of Henle. Then the epithelial layer here is very thin, squamous, cuboidal for quick absorption and excretion through osmosis. Remember, another requirement for the organs is that they be thin and large surface area to allow for quick absorption. So it allows for quick absorption and excretion through osmosis. The hormone aldosterone regulates the reabsorption of salts in that tubule. So we've got two hormones here which play a role. We've got ADH. It's secreted by it's mainly secreted in the brain, right? Yes, but it is actually so in the brain, it would send a message to the adrenal glands. Remember when I showed you, I don't know if it's here, that the kidneys, you have your kidneys, two kidneys here. At the top here, you've got adrenal glands, these ones at the top. That's where this hormone, ADH and aldosterone, are actually secreted. No, that's where aldosterone is secreted. ADH, yes, is indeed secreted from the brain. But these two here, the aldosterone, there are these glands here, the adrenal glands are the ones responsible for that function. So they will secrete these hormones. Why are these hormones important? They regulate the water concentrations there in the blood, and they also regulate salt concentration. So they are responsible for both processes, water concentration and salt concentration. As we've seen here, it is what's in the brain, and the hormone, it determines here. ADH will determine how much water needs to be reabsorbed back into the bloodstream. Remember there in reabsorption, in ultrafiltration, the water, glucose, amino acids were removed or were filtered into the capsular space. They were filtered into the capsular space, right? That water is reabsorbed by this one, the distal convoluted tubule and the loop of Henle. That is the one that is responsible for that. Then aldosterone will regulate the reabsorption of salt. So ADH will determine which water. So here, let me show you. ADH is water. It regulates water. Remember that. And then aldosterone regulates salts. Those two are very important to be regulated. There. ADH, water, aldosterone, salts, which are found there, these hormones here on the adrenal glands, on the kidneys. Potassium ions are all reabsorbed in the proximal convoluted tubule and are then secreted into the distal convoluted tubule. The secretion there is enhanced by aldosterone. Why? This is a salt, guys. Potassium ion is a salt, and aldosterone regulates the reabsorption of salts. So that's why it is regulated by aldosterone. But this one is reabsorbed in the proximal convoluted tubule, as opposed to where the water is reabsorbed. The water is reabsorbed in the distal convoluted tubule and the loop of Henle. But this one is reabsorbed in the proximal. And then secreted into the distal. So it's reabsorbed in the proximal, then secreted into the distal. At the end of the day, all of them will end up in that distal convoluted tubule, right? The epithelial layer here, remember the epithelial layer, the epithelial layer, these cells, these ones are the epithelial layer cells. Those ones here on the lining. It is those epithelial layer cells that will need to be what? They are very thin, they are squamous and cuboidal for what? Why is it the structure like that? Remember, I always mention and I always emphasize form, fit, function. The structure is always designed in such a way that will aid in the functioning. So it is like this so that it can allow for quick absorption and excretion. That is why the structure is like that. So we will further discuss osmoregulation step by step. Ne? Process 3 is tubular excretion. Remember, they are now in the tubes. These tubes here, the distal convoluted tubule. They are there, right? Because they were reabsorbed into the distal convoluted tubule. Now, from the tubule, the epithelial of the nephron tubules also excrete waste into the tubule. So the waste is in the convoluted tubule, distal convoluted tubule. The epithelial of the nephron tubules will also excrete waste into that tubule. So everything will be directed to that tubule there. Here it is the urea, uric acid, creatinine, water, and excess minerals and vitamins will pass from the collecting tubule into the ureter and the bladder as urine. So from that tubule, the convoluted tubule, where is it here? I want us to look at it. Distal convoluted tubule here. Remember the reabsorption happened here. Distal, where in ultrafiltration, it happened here. Ultrafiltration. Remember, ultrafiltration happened in the glomerulus and Bowman's capsule over there. That's where ultrafiltration occurred, step process 1. Process 2 is reabsorption, whereby it was reabsorbed into this distal convoluted tubule there. This one, that's coiling that I'm drawing. There, that is that, this is the proximal one, right? Where the salts are transmitted to. But the distal one, where the other substances are reabsorbed into. So through what, remember we mentioned through the loop of Henle and then as well in the distal. The potassium ions will be here. Potassium ions are reabsorbed here and then they will be secreted to the distal convoluted tubule. But all the other ones will be reabsorbed in the distal convoluted tubule. And then epithelial cells, like we've mentioned, and the other cell, the other tubules will also move this through here, through this distal convoluted. And then they will, all these substances will then move to the collecting tubule. Because they are there, they will then move to the collecting tubule. Then from the collecting tubule, where are they going? They will pass from the collecting tubule into the ureter and the bladder. So do you understand the connection now? I want to go find the image of the kidney. So they would move there from the collecting tubules, then into the ureter. Here is the ureter. So they will come from there. Those nephrons there, they're coming from the nephrons. Now it's those waste products coming through to the ureter. Then from the ureter to the bladder. I hope it's starting you can get the full picture now of what happens. Ne? Then process 4, tubular secretion and pH control. The tubular secretion of hydrogen ions is important in maintaining the correct pH of the blood. Remember the pH scale? How is it like? You've got up to 14, right? You've got up to 14. Let's say we've got here 7 and then up to 1 D. At 7, it's a neutral phase. It's neutral. At 14, it's an alkaline process. From 7 to 14, it's alkaline. And then 6 downwards, it's acidic. So when you have too much of the hydrogen ions, they will what? They will cause the blood to be more acidic. they will lower the pH level in the blood, so causing the blood to be more acidic. So the tubular secretion of these hydrogen ions are important in maintaining the correct pH of the blood, because the blood shouldn't be acidic. That's the thing. So it should be regulated as well. The hydrogen ion pumps are found in the membranes of the epithelial cells. When the pH of the blood rises, whereby it becomes too alkaline, remember when it rises, it means it's going above 6 there, it's above 7. Above 7, it's alkaline. There, it becomes alkaline. So when the pH level rises, it is becoming alkaline, too alkaline. And then fewer H+ or hydrogen ions are secreted from the blood into the renal tubules. But when the pH of the blood drops, whereby it's lower than 7, it's becoming acidic, more hydrogen ions are secreted from the blood into the renal tubules, because if it's acidic, it means you have more of the hydrogen ions. That's why they will then become secreted from the blood, because it's the blood that's becoming too acidic. So they will try and remove these hydrogen ions from the blood into the renal tubules. But if it's too alkaline, then more of these hydrogen ions will be secreted into the blood so that it can lower the alkaline levels. You understand the regulation that happens? If the concentration is too high, a particular hormone or substance will be secreted to bring the concentration down. But if the concentration is too low, then it will be secreted to ensure it brings it back up. The whole point is that it must be kept at optimal, normal concentrations. That's what the body is always up to ensure normal concentrations in the body. And then process 5 is urine formation. Waste substances are those that cannot be used by the body. So remember, the water and the sugars and some salts were needed by the body. That's why they were reabsorbed. Everything else that cannot be used by the body and is not needed by the body is then excreted in the form of urine here. What are those substances? It's like ammonia, urea, uric acid, creatinine, and excess water. Those ones are not, if it's not needed by the body at that particular time, it will excrete it. These ones are then secreted into the tubular fluid by the tubular cells of the kidney. Together they make up urine. So urine is a combination of all of these different substances: urea, uric acid, creatinine, excess water. It's a combination of all of these. The urine processed from the convoluted tubules into the collecting tubules, then the kidney pelvis. So remember, I showed you in the diagram that the urine will pass from those convoluted tubules into the collecting tubules, then the kidney pelvis. There, let's go show you again. From the convoluted tubules here, these are the convoluted tubules. Then into the collecting tubule. Here, you see it flows. Then from the collecting tubules, then to the ureter, where it will be excreted. Is this way, is it? Yeah, then the kidney pelvis there, well, they're going to be excreted. The ureter, which is that one that collects the urine from the kidney to the bladder, will carry this urine to be temporarily stored in the urinary bladder. Urination passes the urine through the urethra, 1 to 2 liters daily. So from the bladder to the urethra, whereby it is now exiting the body, it's being excreted. But you see what a complex process it was. And now you see the formation of urine. It is from the blood, then it was filtered, then other molecules that were reabsorbed, that were filtered but are important for the body, were reabsorbed back into the blood. Then the whole process whereby the excretion of other components into the tubule were then taken there. Then the pH had to be balanced out because they're changing different substances changes the pH. So balancing of the pH level of the blood, then urine formation and excretion. So that's 5. We are done with this process. Are you clear? Are you okay? Do you understand? Do you need my help with anything? There, it's that one, that diagram I kept going back to. See there, afferent, it goes in here, then in here, whereby now the filtration happens, then it goes through here, tubular reabsorption, it's reabsorbing it, then into the distal convoluted tubule, then to the collecting duct, then collecting duct to the ureter, then it will be excreted, ureter, then it will be excreted. So we've gone through all the 5 processes that occur during urine formation or the functioning of the nephron. So now you understand the functioning of your nephron. The processes: ultrafiltration, reabsorption, tubular excretion, tubular secretion and pH control, then urine formation. Now, just exercise 3 before we wrap it up. So exercise 3, question 1. Explain how the difference in diameter of the efferent and afferent arteriole is responsible for the process that occurs in the Malpighian body. Remember, Malpighian body is where you have the Bowman's capsule and the glomerulus, ne? That one here, this one is the Malpighian body. Remember that, this here. So what role do the differences in diameter have here? Efferent one is narrower and the afferent arteriole is wide. So what difference does it make? What exactly, well, the difference in diameter, how is then is responsible for the process? The large diameter afferent arteriole and small diameter efferent, remember I gave you a hint, afferent is the large diameter, and then efferent is the small or narrow diameter. So ALES, I don't know how you remember that, but yeah. This what the difference here, it causes an increase in blood pressure. Why? Because on the one end it's wide, and then on the other end is low. So when you push something in here, when the blood enters, the pressure increases. And that pressure increasing then forces the food, water, and salt out of the blood through the fenestrae between the podocytes into the capsular space. So it's the whole point. It ensures that the blood pressure increases so that the passing through of these or the filtration of the blood, whereby it removes these substances, occurs faster. So that's the role it plays, to increase blood pressure and results in faster rate of filtration or passing through of blood pressure, so that the filtration can occur quicker. You understand the difference, right? Question 2, briefly describe how the cells lining the proximal, which is the first convoluted tubules of the kidneys, are well suited to their functioning. This is the one we are talking about. These are the proximal convoluted tubules, these ones here. Then here, it's the distal convoluted tubule. So they are asking about how these cells play their role here in the proximal convoluted tubule. You see, you have 2 types of convoluted tubules. You have the proximal, you have the distal. How are these ones, how are they well suited for their functioning? Remember, I explained that the cells in the proximal convoluted tubule, they have what we call the microvilli, which are responsible to increase in the surface area. They aid in the increasing of the surface area. The function there is to assist in the reabsorption. With the increased surface area, then there's more space and reabsorption occurs faster and more efficiently. Another thing is those cells have what we call the mitochondria, which is the powerhouse of the cell. And in the mitochondria, that's where cellular respiration takes place. So that means that's where energy is produced. Amongst other things, the product there is ATP, which is energy. So the function is energy production for reabsorption. Why do you need energy production? Because the reabsorption occurs either through osmosis or diffusion, which are passive processes. But the one that requires energy is the active transport. So you need energy to facilitate in that active transport of reabsorption. Remember, I even made the example of the slide whereby you are trying to climb the water slide. That's the example of active energy, active transport, my friend, active transport. Then The other structure that these cells have is the single layer of cuboidal cells. What helps? Why does it help? The single layer means it is thin. So by it being thin, it happens easy diffusion. Diffusion occurs easier. Like I made an example when we did the gaseous exchange organs that if you were to cook a potato whilst it's still round and whole, it would take a long time for it to get fully cooked. Ne? But if you were to cut that potato into slices, then it would cook very, very fast. So that's what the thin size here, because it's a single layer, it is a smaller thin size, and it facilitates in easy diffusion across the cells. So I hope that is clear, né, guys? Then the last one, explain what tubule absorption and excretion is in the nephron. Want to know what tubule absorption and excretion is in the nephron? Potassium ions are completely reabsorbed in the proximal convoluted tubule and are then secreted into the distal convoluted tubule. This secretion is enhanced by the hormone aldosterone. Then hydrogen ions are also excreted into the distal convoluted tubules, causing the urine to have an acidic pH. Remember, we are removing hydrogen ions from the blood because you don't want the blood to become acidic. You don't want the blood to become too alkaline either. You just want it to be okay or basic. So these hydrogen ions will be removed from the blood, then will be excreted into the distal convoluted tubules, which will then cause the urine to have an acidic pH. Okay, guys, are you okay? We run out of time, né? Yeah, we're almost out of time now. So this experiment, I want to get the video. I'll show you how the dissection of the kidney looks like. So I'll try get a video, but these are just instructions and some questions. So I'll get a video to make it more practical. But yeah, guys, do you have any questions? Remember, if you're uncomfortable here, you are more than welcome to send me an email and I can explain further whatever we learned in class. Yeah? Access Snaplify app to get access to various textbooks for free until December this year. So literally go feast yourself, guys, for free. You'd never get such an opportunity. And then I personally use the Via Africa Grade 10 Learners book. So any of those sources would be very helpful for you. Go through them, it will help you. Always put in the extra effort in your work. You will see the results. And then for more information, yeah, and Africa 10 Gigs videos on YouTube, go through Facebook or whatever. Anyway, you can find us, type in africa10gigs.co.za, even the website, www.africa10gigs.co.za. Thank you so much for everything today, guys. Take care of yourselves. I will see you tomorrow. Bye.